Thank you very much. A lot of you know who I am, but those of you that don't, you can look me up on LinkedIn. I'm not going to talk about my vast experience except to say that I'm the founder or author of Data Vault, and I've got 30 years plus in the industry of data and data warehousing and BI and all kinds of other things. I started life as an assembly level coder, so in case you're wondering about my background in writing code and applications, I've been there, done that. I will talk to you just briefly, introduce you to DataVaultAlliance.com website that we built. We just launched it, and we have about 345 community members today. It's an engaged community with forums and e-learning, and we're in the process of adding more e-learning modules, what we call 1-hour micro lessons. We don't have very many of those out there today, but in the future. So if you feel like taking a hands-on and doing a micro lesson that solves a specific topic or a focus, then that will be available to you on DataVaultAlliance.com. So head on over and check it out. Let me know what you think. So a lot of you have been through training, so some of this will be reviews, so I'm not going to spend a lot of time on this. This is just sort of a short introduction and overview. I was asked to compare Data Vault to other modeling approaches and other methodologies, so we'll talk a little bit about this. The first thing I want to say is when you compare Data Vault, you have to break it into a couple of different pieces. You can't just simply compare Data Vault to, say, Kimball. That doesn't add up. You have to compare the methodology, the approach of Data Vault to the methodology or the approach of Kimball, for example, versus a waterfall approach versus an agile approach, and how you work. That would be a proper comparison. You have to then break out and compare the models. So Data Vault modeling versus third normal form modeling versus star schema modeling. So if you're going to compare these things, you need to break it apart and you need to compare apples to apples. It's unfair to say Data Vault compared to Kimball and then just go off the board and say this, and this, because those things don't align. So when you look at third normal form data warehousing, this is a tendency that a lot of OLTP developers have. They come from the operational world and they want to build everything in third normal form according to 3NF rules. And there are also a lot of industry logical data models that are sold by various vendors that claim to offer a prepackaged data warehouse model. The problem with these industry models that customers have, one of the problems is they're too highly abstracted. They're sitting at such a high level that it takes an awful lot of business rules to integrate the data sets and run all the conformity, and that's all well and good in the customization and the initial run, but you spend 6 to 9 months building it, and then when you get done, by then the business has shifted and moved and the conformity and the rules don't match anymore, and then it's a nightmare to try and rebuild all the conformity for across the business to get these industry models loaded. So they're great as guidelines so that you don't miss anything, but they really should be just conceptual models. They should not represent the physical world. When you get down into the physical and you look at third normal form as a data warehouse, you see these problems, cascading change impacts. And if you look over on the left, you see university ID and university start date. And this is the way third normal form, if it's done properly as a data warehouse, you have to incorporate a start date with whatever the ID of the record is, and that becomes your primary key. And what happens when a delta comes in to a university record, and I'm not showing any of the other attributes there, is that you then have to wonder, how do I assign a current class that's attached to a previous start date? How do I reassign that current class to the current university start date and the current university ID because a delta came in at the higher level? So this is what we call cascading change impact. And it not just affects the data set, but it affects the model, it affects the processes, it affects the queries and the way queries are written and queries are working. To solve this problem, many third normal form modelers take a shortcut and simply do what operational apps do and strip the start date out of the primary key. And then they say, well, I'm just going to assign a new university ID to every delta record. Well, that still has the same problem. just because the university ID changes doesn't mean you resolve the cascading change impact. You still have to replicate the new university ID into the old class and the old instructor, but what happens is you now have to copy those records and reinsert them and reattach them to the new university ID in order for that cascade change to occur to represent those records. So the deeper your taxonomy and the deeper your ontology, or the deeper in your model you go, the more cascading impacts you have, the more rigid your third normal form data warehouse becomes. This is one of the reasons why we don't use third normal form in data warehousing. For many, many years, it's been abandoned in terms of a quote best practice. But we still get the operational application developers wanting to do this way because that's what they were taught in school, and they understand operational applications. It's fine for transactions that are always current. It's not good for data over time. So this is part of the problem. It also introduces massive load dependencies, and you can't really handle late arriving data or real-time data streams, and of course it's rigid and inflexible to changes. So then we bring in Kimball, and you see over here on the right hand side you've got source systems that load a landing zone and a PSA, and PSA stands for persistent stage area, and you've got all these federated dimensional models that act as your quote-unquote data warehouse. But you've got business rule complexity, dimensional overload, and load dependencies, and everybody says, well, you know, this is the right way to do it, and this is what the industry has been doing for 20 years. Why do we need Data Vault? You know, when I kick off a new project and I build a 5 dimensions and a single fact table, I can do it in 2 months or 2 weeks or 3 weeks, or, you know, it works great. It's agile, it's fast. Yes, that's true. When you build it for a very specific business purpose and you build it for non-integrated, you build a silo, and you can build it very, very fast. It is extremely agile to build and get an answer set out with a single current set of business logic for a specific business unit, but it doesn't span the enterprise. And my question to you, if you're thinking of doing things this way, is what is the definition of insanity? It's doing the same thing over and over again and expecting a different result. Well, we've been doing this in the industry for 20 years, and it's been failing. And I can point to customer after customer after customer where enterprise level data warehouses, this approach simply fails. It fails for a number of reasons. So we're going to take a look at those reasons here just in a second. The sad part is that many are trying this again. They're saying, well, we have a data lake, which is really just a data dump, a landing zone, and we're dumping files into it, and we can just redo this. Well, if you're going to rebuild using an approach and a methodology that hasn't worked in 20 years, what makes you think that just because you have a data lake or a new technology like Snowflake DB, for example, that all of a sudden the old stuff that hasn't worked for 20 years is going to work for you now? You need to change the way you're thinking. But here are some of the problems with this approach. Complex patterns in loading conformed dimensions, high rates of production failures, high rates of data failures, high rates of problems and issues when the business rules changes, slow load times over big volumes. And one of the biggest issues is, if this is your data warehouse and it's post-business rules, when a business rule changes, you have to pull all this data out of the star or the dimension, reformat it, refigure it, run it through the rule, and then reload it. And what you lose is history. Data warehouse, the definition of a data warehouse is to be immutable. By doing this and by changing the data in your conformed dimension to meet today's business rules, you are breaking the very foundational definition of a data warehouse to be immutable. It's no longer immutable, and therefore you lose auditability, you lose all kinds of best practices, and furthermore, if you have any sort of scale, and I'm talking about dimensions with 360 billion records in it, and you don't believe me, I've got a case here that we're going to talk about where this is actually happening, but 360 billion records in one dimension, multiply that by 50 tables, and now you got a volume problem. Can you really afford to re-engineer every single record in that 360 billion row table that's ever growing every time a business rule changes? I don't think so. So real time, is it truly supported, right? And there's this whole notion, well, I'm just going to insert a dummy record into my conformed dimension and when the fact arrives, and then I'm going to do a delta against the dummy record. Well, that works technically, but when you're doing real-time streaming at 2.2 billion records every hour, you can't double your inserts and you can't double your data size just to insert a dummy dimension record because a fact arrives. Your performance of doubling your inserts, it throws the I/O through the roof. It's unbelievable how this particular architecture and this data model breaks at scale. So then the other question here is, what happens if the business needs a cube instead of a dimensional model? How do you build one? Well, then you have to put it downstream, and that causes other problems when the cube falls out of sync of the dimensional model. So what happens to history when a corporate calculation changes? And of course, landing zones, if you talk about, well, I'm just going to throw a data virtualization engine on top of a landing zone. Okay, fine. But what happens if your landing zone doesn't contain delta or delta-driven data? And most landing zones don't. And most landing zones are simply data dumps. And also, most landing zones are not integrated by business key. And this is the problem that data scientists have. Is they're simply handed a file, or they're given a file, or they go get a file, and they're not given metadata. They're not given governance. They're not given any sort of structure that defines what's in the file. And so they spend 80 to 90% of their time profiling the data. When we've been doing that for the last 15 years, we have best practices, we have productionalization rules, we have routines on how to do it, and yet the data scientists aren't leveraging that. One of the problems is there's this whole split between the data science community and the BI EDW community. If you look at an Agile manifesto, one of the Agile manifesto declarations is that you collaborate. We have to collaborate with the business data scientists. They have to learn to collaborate with us. We have to work together to solve these problems. It isn't just a data warehousing BI or an us versus them issue. And then finally, if you've got this old model, how do you separate or protect PII or classified information if it's buried in a conformed dimension that's running through rules? There's all kinds of problems and impacts, and I know you guys deal with PII, privately identifiable information. Sorry about that, for those of you that wonder what the acronym is. And GDPR, General Data Protection Privacy Regulations, and so on. So classified information, so lots of different things. So introducing Data Vault 2, a lot of you know what it is. I'm going to give this to you anyway, and I won't spend much time on this piece. So we've got an architecture. This is the Data Vault architecture. We do incorporate landing zones. We do incorporate data science. We do incorporate the unstructured data, document derivations, and all kinds of things that we need to do in landing zones and file stores in what we call new SQL or NoSQL engines. So we do leverage the NoSQL platforms. If you've got one, we should leverage it. If you need it, there's a business reason for it, we should build a hybrid solution. And that's what you see here. See, your data warehouse and your data vault shouldn't be just a relational data store. It should be a hybrid solution that leverages both NoSQL, new SQL, and your existing analytical processes and data that you can store in a structured format. So your real-time feeds are going to feed both. You're going to land stuff in files for the data science teams. You're going to land stuff directly into the data warehouse, bypassing the staging area when you're dealing with real-time. And then we produce something called information marts. This is new to the data science world and the data science teams. They don't like this idea that they have to go through some rigor or some governance to put things into production. But I got news for you. If you want to stop the failures, or you want to stop false positives, which come out of neural nets frequently, and some of these data science quote models that they build, you have to establish governance. Good governance is a must, a necessity going forward, whether you're doing enterprise data warehousing or data science in this landscape. It's called productionalization. And so this is another point at which the data science team must collaborate with us in the data warehousing world to provide accurate, trustable answers for the business. And so this is what we call the information marts. It is a productionalization process or set of processes where we have best practices and standards that we can apply. I'm not saying data science shouldn't access raw data. I never said that. I'm not saying data science teams shouldn't produce stuff in a sandbox. I never said that. I'm not saying that data science teams shouldn't use raw production data. I never said that either. What I am saying is when they're ready to put something in front of the business, it needs to go through QA test, all the same rigors, and it needs to go into production using deployment strategies and best practices the same way we do to avoid the errors and the false positives getting into the hands of the business and destroying trust. Then you've got data visualization and you've got managed self-service BI. There is a bit of that. There are some sandbox and playgrounds down in the landing zones and some playgrounds in the staging areas with raw data that we allow certain users who are allowed to have access or logins to, but it's governed access. It's controlled access, and that's why we call it managed self-service BI. So this is what we do with the Data Vault. This is the architecture combined with the methodology and the best practices. And you can see there's a flow of data. And down below, we've got this thing called automation and generation. We like to do 98% automated all the way up into the raw warehouse. Now, you can only achieve these statistical numbers if you stick to the standards. If you break the standards of the Data Vault that have been tried and true and built over 10 years of research and design and 30,000 test cases at Lockheed Martin, then you're going to suffer the consequences. If you break the standards of the data model, you're going to suffer the consequences of re-engineering or the consequences of inability to scale or inability to absorb real time. The more band-aids you apply or the more changes or adaptations you apply to the model, the worse it gets. The more adaptations you apply to your process layers and the more you stray from the standards that we teach, the worse it gets. So these are some of the downfalls or pitfalls. We do split up as teams grow. We start out with a single team that does both data acquisition and information provisioning. But as the teams grow, as the environment matures, we start to split the teams so that we can handle the resource load. The data acquisition teams actually shrink as we cover the entire business. There's less and less need to add new tables and add new source systems. There's more and more need to define metadata from additional external systems and help the data scientists do some of that work that they need to do. And that's where the data acquisition teams spend a lot of their time. And then information provisioning teams, there's more and more demand. If you build a data warehouse properly, there's more and more business demand for different reports and different consolidations and faster changes to the business rules. So what we do is we decouple the business rules from the data warehouse. We make ingestion easy, we make everything agile, and we adjust to the business needs. And we apply that same concept to the data science realm and the landing zones and how we manage or govern the process by which data science data makes it into the hands of productionalization and production systems. You've got to change the way you work. You've got to change the people. You've got to change the process. You've got to change the tech if you want to change the outcome. As a lot of people know, they attribute Einstein with this whole thing of, hey, look, the definition of insanity is doing the same thing over and over again and expecting a different result. Well, you want a different result? You got to learn to do it a different way. You got to learn to think differently. You got to learn to change your model, change your process, change the way you work. So the Data Vault 2.0 is really a system of business intelligence that helps you change not only the way you work and how you do your work, including automation and leveraging an automation tool, but it also helps you change the way you design and architect your solution, the way you store your data, the way you integrate and build hybrid solutions. So it's a lot more than just a data modeling technique. It's a complete methodology. A lot of people look at Data Vault or read out on the web that Data Vault is just a data model and this is hub and spoke thing. And well, yeah, that's a piece of it. But if you use just the Data Vault model and you ignore the process standards, you're going to fall down. You're going to end up right back where you are today. You might as well just forget Data Vault and go build Kimball. And then you won't fail in 3 months, but you'll fail in 6 or 9 months from now, and you'll have to come right back to the table. If this weren't the case, if Kimball were actually successful at the enterprise scale, we wouldn't have a need to discuss Data Vault today. So that's something to think about. So what does a Data Vault look like for those of you that have never seen a data model? This is a conceptual view. We've got this notion of hubs or unique list of business keys, and we do that so that we can tie the data to the business process. Now, a lot of people go, well, I don't need business keys. Okay, fine. How do you do a delta? Forget data vault. How do you do a delta in a type 2 dimension? How? There's only one way. You have to identify the business key. You cannot do a delta against any existing record without a business key. You need some form of consistent key to do a delta process. And so this is something fundamental to data warehousing that OLTP doesn't have to deal with because they always have a current record. Okay, so then we have links and associations, or relationships and associations, and you can see here in the data warehouse we have to deal with something called a many-to-many. That means I could have many customers attached to many products, attached to many orders. And the reason why we do a many-to-many is because of business rules changes over time. Today, the business says one customer can have many products and many orders. And I look at the data 5 years ago when we go to load history, and all of a sudden one product could have many customers, or one order could have many customers 5 years ago. Well, the last thing you want to do is end up in a situation, listen closely, where you have to re-engineer your data model just because the data broke the rule. Just because 5 years ago the data said it was different. You want to become a data-driven enterprise, you want to have data-driven analytics, you better have a flexible data model in your warehouse that enables you to run those data-driven analytics. The point is, the warehouse shouldn't care what the rule was, or what the rule is, or what the rule will be 2 years from now. It should work. Simply work. It should load the data that exists, whatever the source system gives it, and it should simply load it up and allow queries to determine what meets today's business rule, what breaks today's business rules. And this is how we get our analytics. We look at the business processes by querying the data vault, saying, well, which one of these customers, or which ones, today's business rule says a customer can have many orders, but an order has to be attached to one and only one customer. So now if you load all that data, you can now run the query that says, give me all the orders and tell me which source system's producing them and what frequency, all the orders that have more than one customer. And then you can run, that's called an anti-pattern in the data, and you can test the application, the source application's ability to enforce the business rule at the source system level. So this is where we talk about some of the analytics that you can get out of even a simple model just like this, if you do it right. Then we have this concept called the satellites, which are descriptive data over time, and that's where the data warehousing goes. So some of the benefits that we have, again, model and methodology and architecture, they all three go together. I'm not going to bore you to death by reading these or explaining them. I'm going to give you the slides if you want, and of course we're being recorded, so you'll probably have access to the recording as well. But I'll send the slides to Greg Frank and he can distribute them. So methodology, implementation, architecture, benefits. We have all these benefits if you stick to the standards. If you break the standards, you're going to break all the engineering that was put in behind them, and you're going to stray off course, and you're going to end up right back where you are today. One of the standards we have splits this concept of business rules into hard and soft rules. The hard rules are those rules that don't change, things like data type mappings, things like normalization of XML or JSON, splitting those out into groups, for example. Those are simple kinds of hard rules. However, we have this whole category called soft rules. When we split or divide the soft rules from the hard rules, we can build an auditable data warehouse with rules that don't change over time, and then we can build BI solutions, one to many to hundreds, and we can retire BI solutions. We can build a star schema today that we retire 3 months from now and build a completely new one, as long as and build a new one tomorrow. As long as we're backing up and version controlling the rules that built that star schema, we can remain auditable in our information delivery past those soft business rules. When we decouple this, we can also build a unit-based business object, so a star schema for sales, and we can build a different one with different rules for finance based on the same data. And then we can explain why the numbers don't match if they don't match. It's actually traceable and auditable and explainable if you do it this way. So one of the things we have here, again, this is another view of electronic health record, and you've got adaptability to change with no re-engineering. If you start with one hub and 3 satellites for an electronic health record and you want to add a clinician, it's very easy. We pop a link in, which is a many-to-many relationship, and you have a clinician hub with a clinician satellite, and then of course you want to add a patient to this mix. You just add more hubs, links, and satellites. And so this is the model growing organically, and it doesn't require re-engineering. So this is how we run. Now, it does create potentially many objects in your data warehouse layer, or many tables in your data warehouse layer, but it isn't the number of tables. It's how you manage them and what the cost of maintenance is, as well as the ability to get performance out of the end result, and how agile you are in producing your business rules. You can't just measure the number of tables and point at something and go, oh, that has too many tables. Well, I know of a source system called SAP. You ever heard of it? There are over 10,000 tables in just one module alone. Is that too many tables? I mean, come on, really. Let's think about this logistically. Is anybody saying SAP has too many tables? I don't think so. So you can't just point at the data vault model and blame it and say, well, there's too many tables and that's why I can't use it. And that's just the wrong way to think. You got closed-minded thinking there. So here's one of the reasons why I say we don't have re-engineering. So the Department of Defense said to me when I worked for Lockheed Martin, they said, we want a data model and a process and a methodology that we can inherit everything. The models, the processes, the data, the queries, everything from what we call publicly available to what we call protected or private, or in a case of the DoD, what we call secured or high side, right? So classified. They want to then extend it behind closed doors. They want to add things to the model. And you can see here, Hub C1, Link C2, SAT C4, SAT C5, and C6. All of those things in the semi-white or beige structures were added behind closed doors to the model we had in the publicly available system. And then they gave me another requirement. They said, you know what? We actually need, if you go and add SAT NC2, the white ones, and SAT NC4, or you add links or you add more hubs, we need to inherit all of those changes as well. But the kicker is they need to incorporate seamlessly with anything we built behind closed doors with zero re-engineering. And the Data Vault model is the only one in the world that can actually meet these paradigms and do this for the models, for the process, for the data, and the query sets. And so this is how we met the DoD's requirements. Okay, so methods, model, data, approach, design, the way we work, everything else. Now, you can do this. This is really cool. You can change these labels to on-prem and in cloud, and all of a sudden it starts to make a little more sense to what you're building. You could also change these labels to geographic locations. You've got a piece of your data vault in Denver, you've got a piece in San Diego, you've got a piece in Tokyo, a piece in Australia, and you can integrate them all. You can have all these different teams working on different bits, and you can pull it all together. So the Data Vault model allows that to happen. So here are some benefits. I'm not going to bore you to death with the benefits. I'm going to try to finish this up and open it up for conversations here. I've got a few more things to show you. So benefits of Data Vault 2.0, you can see here the biggest ones I'm going to point out: cross-program collaboration, okay, accuracy and auditability with the general ledger. We talked a little bit earlier this morning about gap analysis of business effectiveness, the ability of the source system to enforce its business rules in the operational application, and the ability for the warehouse to detect when those business rules are actually broken if you build a data vault correctly. Automation and generation is a huge one. Absolutely huge. And then of course big data and NoSQL compatibility. So let's talk about data sizes. Let's talk about some test cases, some benefits at work in customers today. So the first one is meeting compliance. AXA Global Insurance, I'm sure you've heard of them. GDPR regulations worldwide, multiple teams worldwide. They have 15 teams around the world that I've dealt with. I have 150 people in IT. So with PII, with Data Vault, and cell level security, we're talking hundreds of terabytes of information. You want to talk about scalability? Let's talk about Micron. Micron uses Data Vault 2.0 and ingests 3.2 trillion records from 10 manufacturing facilities around the world. That's 2.2 billion records an hour in real time into Data Vault 2.0. Okay, streaming from 10 worldwide manufacturing facilities. This is IoT machine generated data. You guys want to talk about healthcare and health insurance? You guys are on the cusp of IoT devices in the medical industry to determine people at risk and to determine what's going on with the health, the immediate health of the people in the hospitals or in the ER or in the recovery rooms and in PT, for example, recovery therapy. So lots of different things. Sub-second query response times across billions of records. They have about, I think at last count, 150 objects or tables in their data vault, and each one of their data vault tables with 3.2 trillion records, each one of their data vault tables averages 360 billion records every day in terms of delta processing. Now, obviously, with 3.2 trillion facts or IoT generated data sets, you're getting a tremendous amount of infusion into quote unquote the link structures, and that's exactly what's happening at certain points. So let's talk about master data management. The Department of Defense uses Data Vault and its ability to produce master data, which again is a concern in healthcare. You want to identify a patient that has multiple records or has identified themselves multiple ways to the same doctor or different doctors, or perhaps the doctors have recorded their names slightly different, those kinds of different things. So master data is a big thing, but insider threat and identity resolution using business key attribution and identification. Now, the DoD also applies data mining and neural nets and AI and data science and machine learning and all those wonderful things directly against the Data Vault collected data, so that they can rearrange the data set as needed using all the links and associations and produce new models, new BI, new discoveries, and of course false positives, which they're watching for, and they have human intervention to address. They don't want to come out and arrest the wrong person, right? And then rapid agile, you want to talk about agile and turnarounds. I work with a company called NetJets. We reduced turnaround time from 4 weeks to 2 days with a team of 10 people, completing productionization from start to finish in 2 days with near zero defects. And that was also with the introduction of an automation tool. Okay, and then of course SCI, CMMI level 5 compliance. QSuper in Australia reached CMMI level 5 repeatability and optimization 7 weeks after leveraging Data Vault 2.0 methodology. The QSuper at that time was the first one to meet what they call APRA reporting requirements, which is stringent requirements set by the government for auditability. All right, so let's finish this up. I've got a few more slides to go through, but what does it take to execute successfully? You have to have automation to help you manage the metadata, to help you manage governance, to help you manage the objects, to also generate to the standards and the patterns. Who in this room, and don't raise your hand because I can't see you, but who in this room wants to write yet another staging load? I didn't think so. So why not just stick to the standards, stick to the patterns, and let an automation tool generate it for you? You need collaboration, you need standards, you need a desire to do things differently. You definitely need training, as some of you can attest to who've been through the training, but you also got to practice. So let's go back to case studies. This was asked for. Sorry about the cutoff there. It should say case study comparison, not compariso. But people, information, and technology. So this is a case study done by one of my friends. She is now at Chestnut Hill Technologies. So the first company, A, non-Data Vault. This is their setup. Hybrid data warehouse, Inman, Kimball, EDW, pattern design. It was not Data Vault based. It was third normal form based, I believe. Unix, Oracle, Informatica, SQL Prox, and so on. They started with 10 people. The approach with Data Vault, they started with 13 people. And this was the environment they had. So EDW, Kimball, Star Schema, Linux, SQL Server, Informatica, SQL Prox, RabbitMQ, and so on. But let's talk about the results. So this was the architecture. At the top there, Company A had a 3-tier architecture. They had 3 times the effort for development turnaround. They had a batch daily window by 8 a.m. And they ran out of the window. They couldn't push any more data in because the window closed and the infrastructure couldn't handle more data in a batch. You don't want to run batch anymore. You want to mature your data warehouse to a real-time solution. And if you're not ready to do that, you should be, because IoT is here. And it's here to stay, and it can benefit your business multiple ways. All right, so they had 3 data failures per day. With the Data Vault, no data failures ever. It processes jobs based on data dependencies, some jobs in parallel. Anyway, you can see the rest of this. The biggest thing here is you look at the resource count. Grew from 10 to 75 people in a 15-year period. That's 4.3 new people per year to maintain the warehouse. Over on the right-hand side with the Data Vault, 13 to 16 people over a 5-year period. These are actual metrics pulled from a customer. And 0.6 new resources per year, although how you hire 0.6 of a person, I have no idea. But that's how the metrics worked out. But you can see there's also one hop architecture. They did not have, let me just qualify, they did not have massive data volumes for this solution. So they were able to eliminate the stage area. They didn't have a landing zone or any of those batch cycles. Everything was run real time directly to the Data Vault. They did leverage pits and bridges, or point in time and bridge tables, to get the data out. So here's a Warescape case study. I wasn't going to use it, but I want to talk a little bit about from SQL Server to Snowflake using Warescape automation in Data Vault 2.0. They created the first Data Vault design in Warescape within 3 days. The previous effort, they spent 9 months spinning the wheels with 0 production output before Data Vault, before Warescape. So some interesting things there. I went into a large food distributor and food wholesaler, which I can't tell you their name, and we did the same thing. We accomplished in 4 days with 10 people what took the same team previously roughly 6 months to accomplish, and we did it in 4 days, complete with 3 iterations of the BI. That was one, what did we have? We had 2 reports, and we had 2 star schemas at the other end. We had complex transactions coming in. We had roughly 15 million records to deal with in the case study. Now, Micron, I told you a little bit about this. You can talk about Micron happened to be a Warescape case study as well as a Data Vault 2.0 case study. So they implemented the foundation for the global enterprise warehouse in 90 days, delivered prototypes in less than an hour, improved the speed. You can read the rest. Vodafone, also Data Vault 2 and Warescape customer, accelerated time to production from 6 months to 2 days. If that's not agility, I don't know what is. But I will tell you this, the way they do this is by sticking to the standards, okay? If you break the standards, you break the metrics, you break the ability to achieve this level of success, okay? So I was asked to say what could go wrong and what possibly are some of the faults or failures that people have had when transitioning to Data Vault. So let's talk about that for a minute. So before you fully accept DV2, or before business fully accepts DV2, business will challenge, they'll question the value of a data warehouse, not just Data Vault. They'll state that data scientists can do all of this. Why do I need IT in a data warehouse at all? Right? They'll think that federated query tools, this is the next step. If you prove to them that data science is valuable, which it is, and useful, and that you need to collaborate with them, the next question they'll jump onto is, but my federated tool engine tells me that, you know, they're believing vendor hype, one size fits all. We've seen this before. In the 80s and 90s, early 90s, they talked about federated query tools. They used to call them EII, Enterprise Information Integration. Go look it up. The only vendor left from that year, or that era, is Composite Software. But even now, they've changed their name, and they call themselves data query, or data, what do they call it? Data virtualization tools is the new label of the day, right? So thinking that data lakes solve everything, this is something else that business will push back on you. It's not just about the data vault, it's about data warehouse. Oh, my data lake can do this. Well, what they're saying, or what they think, is what I showed on the slide at the beginning. we just dump all this data into a file store in the cloud or on-prem or Hadoop, and it will sort itself out. We don't need data profiling. We don't need data mining. We don't need metadata, and that couldn't be further from the truth. So IT faces some challenges too. The first one is a lack of Data Vault 2 training and certification. Those of you that have been through the training class can attest to this, the quality of the class and what we talk about and how this all works. A desire, this is the biggest one, a desire to be lazy. Humans are, me included, inherently lazy, and they want to do things the way they're used to. And if they don't enforce the standards, or QA doesn't enforce the standards and lets things slip into production. You have to have a good QA and a good governance practice. If you don't enforce the standards and you allow things to move to production that break the standards, everyone will start breaking the standards and everything will fall apart. So people are used to doing the things the way they're used to doing them. There is an inherent aversion to change, to doing things new, to accepting the fact that the new way is in fact better and has been tested. So this is an issue. So a desire to, being lazy leads to a desire to break or customize the standards. And when it's done, it breaks the agility, the scalability, the flexibility, and all the mathematics that are behind the solution. So breaking the standards inevitably leads to re-engineering for every business change. It leads you right back to where you are now. If you're going to do this, if you really don't like the Data Vault and don't like the standards, go back and try and continue building star schemas. But I can tell you this, 6 months from now, 9 months from now, you're going to be calling me up going, hey, Dan, it's not working. And I'm going to tell you, you know, I told you. Right? So lack of training and disciplined agile development ways of working. This is something that both IT and the business suffer from. The business analysts don't understand what agile is. They think they do, but they don't. And you have to have the business analysts trained as well as the IT resources so that collaboration can increase and everybody understands how these things work. So thinking that a lift and shift, this is both a business and a tech problem. Somebody says, you know, and I've heard this recently, oh, if we just move to Snowflake database, everything will come out smelling like roses. Lift and shift never works. Boil the platform. If you got garbage data, garbage architecture, if you got problems in your methodology, problems with your agility, simply lifting your data and your model to a new platform, yes, it might make it faster for a little while, but it's not going to solve the fundamental problems. So this is something to think about. Now, challenges after DV2 is fully accepted. And these are my final slides, so I'm almost done, so bear with me. So lack of business support for CDC. All roads lead ultimately to change data capture. If you want to scale, if you want to get to real time, if you want to get to 3.2 billion records in a 24-hour period in real time, you must have change data capture on your source systems. So lack of desire by business to be accountable and auditable for their own business and their own data set, that has to happen, and IT has to train them and push it back. Continuous push for IT to cut corners, claiming that a data lake or a data dump solves all our problems, misunderstandings of master data, good governance procedures, and lack of a senior corporate data architect. So to round this out, lack of desire to adhere to the standards is the #1 problem, even after training. Not getting assessed and not correcting the course as you go, as you build data vaults, leads to failures. Wanting to model everything in Data Vault first before producing any results. This is something that happens even if you've got a good team that wants to stick to the standards. They think they have to build the entire Data Vault model up front before they can put any BI on it. Wrong, 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 wrong. You want to scope horizontally. You can get BI analytics and good quality analytics out of 2 hubs, 1 link, and 1 satellite. You really can. It's just a matter of knowing how. So claiming that a data lake will solve all our problems, you see this a lot. Justifying the cost of utilizing an automation tool. IT tends to get there and says, yes, we want it, yes, we know it, yes, we like it. And business goes, yeah, but it's expensive. What business is forgetting is to measure it against the cost of hiring IT resources instead, and hiring new people and paying for new people. You have to pay for 3 people to do the job that 1 person can do with an automation tool in the same year. That's essentially the base level metric. Lack of understanding of information engineering and tying data to business keys by business processes and so on. So these are the issues. So thank you. Do you have any questions?